Hi, this is the answer key for problem 1 to 5. So number 1, for each order pair, determine where it is a solution to the system of equations. So they give us two equations and the set of points. All we need to do is plug in x and y to check the answer. For example, first equation, 5x plus 4y equal to -1. We're going to plug in first point when x is -2 and y is -2. We will have 5 times -2 plus 4 times -2 equal to -1. And we're going to check, is that true? 5 times -2 is -10 and 4 times -2 is -8. Is that equal to -1? Since they both has negative sign, you add them. That give you -18 equal to -1. And it's clearly that is a false statement. It's not true. Since it's false, you don't need to check the second equation. This is no. It's a not. This point is not a solution. If a point is a solution of the set, they have to satisfy both equations. We're gonna check the second point. 5x plus 4y equal to -1. I'm going to use the same equation, but at this time with x and y, x is going to be -7 and y is -8. So 5 times -7 plus 4 times -8. Okay, we're going to do the same thing to check if this one gives you a true statement. Is this true? 5 times -7 is -35 and 4 times -8 is -32, and that's obviously is not equal to -1. This will give me -77, and this is a false statement. So again, this point is not a solution. I'm going to check no. Next point is 3 and -4. 5x plus 4y equal to -1. So 5 times 3 plus 4 times y, which is -4, equal to -1. And is that true? 5 times 3 is 15 and 4 times 4 is -16 equal to -1. Is that true? 15 minus 16 is -1 equal to -1. That is a true statement. So since it's true, we're going to check the second equation. If it's true on the second equation, it's going to be a solution for this system. My second equation was, or is, 3x minus 2y equal to -5. So 3x, as earlier we say x is 3, minus 2 times the y value is -4, equal to -5. Is that true? 3 times 3 is 9, -4 times -4 is +8, equal to -5. 9 plus 8 is 17, equal to -5. That is a false statement. So this one is also a no, it's not a solution. If this statement is true, this point will be a solution. Unfortunately, it's a false statement on the second equation. Now what we're going to do is check the last one. I'm going to use the same equation, 5x plus 4y equal to -1. Our last point is 5 and 0. So 5 times 5 plus 4 times 0. 4 times 0 equal to -1. Is that true? 5 times 5 is 20. 4 times 0 is 0 equal to -1. And 25 plus 0 is 25. So this is also a false statement. So none of these points is a solution. They all has the answer is no. Number 2, we're going to graph the system. Graph the system below and write its solution. To graph a linear equation, you need to know the following. The slope-intercept form, y equals to mx plus b. The number in front of x is your slope. That will tell you rise over run. And the number after the x gonna be your y-intercept. Y-intercept, when you plug in 0 for x, y going to be equal to b. So that's just the reason why we have 0b as the y-intercept. And that also your starting point, where we start at. So the first equation, you have 6x, negative 6x minus 2y equal to 4. To get y by itself, like the form that we have earlier, we're going to add 6x on both sides. Negative 2y equal to 6x plus 4. Then we divide both sides by negative 2. Y equal to negative 3x minus 2. So our slope will be the number in front of x, m equal to negative 3. To write in the fraction form, that will be negative 3 over 1. And y-intercept going to be 0, negative 2. Alright, so we're going to start at 0, negative 2. This is the starting point. That's the first point we're going to put down on the graph. 0, negative 2. Rise over run. The slope was negative 3, so we go down 3 and we run over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Let's do one more time. 1, 2, 3 over 1. You can use the pattern as many times as you want. This will give you the other points that line on the same line. Okay, we connect the dots. Then we have the graph of the equation. The second equation, we have slope is the number in front of x, so it's negative 3 over 1. And the y-intercept is 0, negative 2. Don't forget to take the sign negative 2 when you write down the y-intercept. So we're going to start at 0, negative 2. And down 3 over 1, down 3 over 1, down 3 over 1. So there's two lines on top of each other. There's two lines on top of each other. So there's going to be infinitely many solution. Infinitely many solution. Because whatever points on the first line is also the same point on the second line. We have the multiple intersection here. Number 3, Jose and Teresa are driving separate cars to Chicago. Jose and Teresa are driving separate cars to Chicago. They begin the trip with full gas tanks. The amounts of gas in gallons remaining in the tank of each car depends on the number of miles driven, as shown below. So we have the x-axis is the mile driven, and the y-axis is the gas remaining in the car. So Teresa car is the blue line and Jose car is the red line. The first question, after 120 miles driven, which car will have more gas remaining? So we're going to look at 120 miles, so it's going to be right here, and we bring it up to the line. So who has the most car in both? So at the blue line, as 120 miles, Teresa still have 18 gallons in the tank. Jose cars has 16 gallons in the tank. So based on the graph, we can say that Teresa has more gas in the tank. Teresa has more gas. How much more gas will it have? So based on 16 and 18, we can have 18 minus 16, which is 2 gallons of gas. So Teresa has 2 more gallons of gas in her car compared to Jose. Part B, after how many miles will the tanks contain the same amount of gas? So we would based on the intersection. So as 180 miles, that is the time Jose car and Teresa cars has the same gas in the tank. if the number of miles driven is less than this, which car will have more gas remaining? So since the number of miles less than 180 miles, which means this section, and based on the previous answer as 120 miles, Teresa has more gas, it's going to be the same answer. So if the number of miles driven less than 180 miles, Teresa cars will have more gas. Number 4. So we're going to graph this like problem 2, I believe, problem 2 that we did earlier. We need the slope. The first equation, you need a slope, which is 5 over 1. And the y-intercept is 0, 2. The difference this time is we need the line is going to be either dotted or solid line. If the equation is less than equal to or greater than equal to or less than equal to, that will be a solid line. If it's greater than or less than without equal sign, that will be a dotted line. So in our case for equation 1, that will be a solid line. Okay. Alright, I will keep going on. I will go ahead graph the first equation. So we start at 0, 2. 5 over 1 till you go up 5 and run over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Since it's a solid line, I will make a solid line go through all the points. Alright, the next part we need is the shaded part. To do the shade, we're gonna do the test point. Okay, I will test 0, 0. We can pick any point as long as it's not on the graph. First equation, we have y less than equal to 5x plus 2. So we're gonna plug in 0 for y and 0 for x. 0 less than equal to 0 plus 2, 0 less than equal to 2, which is true statement, 0 less than 2. 0, 0 is on the right side of the graph, the blue graph, and it's give you a true statement. We shade the area that has that point. Okay, so we shade everything on the right. If it was a false statement, you would shade the other side. Okay, we're going to do the same for number 2. Y less than 2x minus 5. Our slope was negative 2 over 1 and y-intercept is 0, negative 5. Line sin is less than, only without equal sign, that will be a dotted line. And we're going to do, let's graph this one first. 0, negative 5. 0, negative 5 down here. Negative 2 over 1 for the slope, so go down 2 over 1. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. And we use a dotted line to connect the dots. Alright, then we're gonna find test point. Test point, let's say if I choose 0, 0 still, because 0, 0 is not on the line. 0 less than negative 2x, y less than negative 2x minus 5, that would be 0 less than negative 2 times 0 minus 5, 0 less than negative 5, which is a false statement. 0 is 0 greater than negative number, so this is false statement. 0, 0 on the right side of the black dotted line, you're gonna shade everything on the left side of that equation, since the statement is false. Okay, so the solution set will be a part that two lines overlap on top of each other. So solution gonna be right at this section. Solution. Number 5. So we have problem 1. Negative 7x plus 4y less than 28. To graph this equation, we need to get y by itself. So we're going to do it at 7x on both sides. 4y less than 7x plus 28. Then to get rid of 4, you're going to divide by 4 on both sides. So that y by itself less than 7 over 4x plus 7. So slope is the number in front of x. Slope is 7 over 4. Will tell you rise over run. Y-intercept with the starting point is 0, 7. Our line in this case gonna be a dotted line because we just have less than without an equal sign. The test point, we're gonna pick 0, 0. Test point gonna be 0, 0. So y less than 7 over 4x plus 7. And we have 0 for y less than 7 over 4 times 0 for x plus 7. 0 less than 7, this is a true statement. Okay, we're going to start at 0, 7. 0, 7. The slope tell you go up 7 and to the right 4. We have 1, 2, 3, 4, 5, 6, 7. So it's out of my graph. It's solvable, but you can do is reverse the pattern. Instead of look at the slope as 7 over 4, we can look at negative 7 over negative 4, because we know that negative over negative turn into positive. So 7 over 4 is equivalent to negative 7 over negative 4. By write both numerator and denominator by negative sign, we can go down by 7. 2, 3, 4, 5, 6, 7, and go to the left 4 units. And do it again. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. And we connect all the dots by the dotted line. Alright, test point was 0, 0, and it was true statement, so we shade everything on the right side. Okay, and we're going to do the same thing for the second equation. Y greater than 7 over 4x plus 1. So first, the slope is 7 over 4. And y-intercept is 0, 1. Our line is going to be a dotted line because it's greater than only without equal sign. We're going to do test point. Test point 0, 0. Y greater than 7 over 4x plus 1. 0 for y greater than 7 over 4. 0 for x plus 1. 0 greater than 1, which is false. 0 should be less than 1. So we start at the point 0, 0, 1. 0, 1. Up 7. 1, 2, 3, 4, 5, 6, 7 over 4. 1, 2, 3, 4. Or we can reverse, go down 7. 3, 4, 5, 6, 7 over 4. 1, 2, 3, 4. And we connect all the dots by dotted line. Okay. As we see here, there are parallel lines. Okay, for some reason I make a mistake somewhere. Let me check it really quick. Oops. Alright, gonna fix this really quick. 0, 1, I want to make sure that I plug in the point correctly. 1, 2, 3, 4, 5, 6, 7 over 4. 1, 2, 3, 4, correct. Now 7, 1, 2, 3, 4, 5, 6, 7 over 4. 1, 2, 3, 4. So I need to be neat when I connect the dots. Alright. So 0, 0 is right here, which is below the line or on the right side of the line. And they give us the false statement, so we shade everything on the left side of the pink line. Everything on the left side of the pink line. Okay, so we're gonna find the intersection of two line, orange line and pink line. And that solution is between two lines. That's where the shaded are overlap. Alright, that is solution. And on the question they say that point in the solution set. So you can pick point in the solution set. So you can pick any point on the shaded area. For example, I can choose this point. That will be -2, 0. I can prove any point, pick any points, let's say over here. That will be 1, 7. Any point that you choose, as long as it's within the shaded area, that's going to be fine. The third point that I just choose is -4, -2. That is a few examples. You can choose any point in this shaded area.